Hello everyone, this is Algebra. We're looking at section 2.7, practice C today. Section 2.7 is about square roots. So let's start. Evaluate the expression. Number one, plus minus square root of 900. That's square root of 9 is 3. And then 2 zeros within the square root convert to 1 0 outside of it. So plus minus 30. Number two, we have minus square root of 3600. That's 6 times 6 is 36, and then 2 zeros, 1 0 here outside, so minus 60. Square root of 196. This is one of the numbers we discussed last time. You have to remember, like, over 10. You know 1 squared to 10 squared. That's the multiplication part of the multiplication table. But over 10 squared is 11 squared, 12 squared, 13 squared, 14 squared. So this is the 14 squared. So this is 14, because 14 squared is 196. Square root of 676. The closest one to this one that we know is 25 squared. That's 25 squared. That's 625. This is most likely 26 squared, 676. But you can check it always on the side. 6 times 6 is 36, 6 and 3, 6 times 2 is 12, and 3, 15, 2 times 26 is 52, 6, 7, 6, 6, 76, yeah, so it is 26. Number 5, plus minus, and the square root of 324. So this is between, I'll do it here on the side, so this is between, we know that this is between 400, which is what? 20 squared, right? And then 225, which is 15 squared. So we know that this number 324 is between 225 and 400, so it's going to be between 15 and 20. Now the last digit is 4. Okay, so it's either going to be 16, 17, 18, or 19. 6 times 6 is 36, so the last digit is 6, so most likely that's not it. 7 times 7 is 49, 9, so it's 4. 8 times 8 is 64, 4 is the last digit, so most likely it's 18. And you can check on the side here, so 8 times 8 is 64, 4 and 6. 8 times 1 is 8, and 6 is 14, and 1 times 18 is 18, so 4, 2, 324. So yes, it is 18. So plus minus 18, because 18 squared is 324. So that's another quick way. If you can spend 5 to 10 seconds, sure, but if not, you can always use the calculator. But if the instructions say do not use a calculator, then this is the way to go. So we're trying to not only solve problems, but try to think analytically. So next one, number 6, it's minus square root of 484. So that's going to be over 20, because 20 squared is 400. So we have 484. So after 20 is like 21, 22, 23. So 1 times 1 is 1. Most likely it's going to be 22, because 2 times 2 is 4. The last digit is 4. So let's do it here on the side. So 22 times 22. 2 times 22 is 44. And again, 44. 484, exactly 484. So it is 22. So this is minus 22. Minus 22. 7, 8, and 9 approximate the square root to the nearest integer. So square root of 150, we know that we have 11 squared right here is 121, 12 squared is 144, 13 squared is 169. So 150 is going to be between 144 and 169. So this is 144 and 169, and this is minus, so these are minuses here. So this is minus 12, this is minus 13. Minus 12 is greater, so the signs will be like this. And approximate the square root to the nearest integer, so it's going to be minus 12 or minus 13. Well, 150 is closer to 144, or is 150 closer to 169? 150 is closer to 144, because there's a 6 unit difference. 150 minus 144, there's just 6. 169 minus 150, that's 19. So this is closer to minus 12. Next one, number 8, square root of 300. We know that I'm gonna remove these here. So we know that 15 squared is 225, and we know that 20 squared is 400. So 300 is between 225 and 400. So it's 16, 17, 18, 19. And let's multiply these out. So 6 times 6 is 36. 6 and 3 we remember. 6 times 1 is 6 and 3, 9. 16. So this is 6, 5, 256. So 16 is 256. Then 17 squared is 17 times 17. 7 times 7, 49. 9 and 4. 7 times 1, 7 and 4, 11. 17. So this is 982, 289. So we're getting closer to 300, right? So most likely 18 squared is going to be over 300. So 18 times 18, 8 times 8 is 64, 4 and 6, 8 times 1, 8 and 6, 14, 18, 4, 2, 324. So 324, so yes. So 300 is going to be between 289 and 324, so 17 and 18. So this is square root of 289 and square root of 324 on one side. So 300 is closer to 289 or 324. It is closer to 289 because there's an 11-point difference here. The difference is 24. So square root of 289 is 17. So this is approximately 17. Next one, 425. So 20 squared we know is 400. I'm just going to remove this one here. And then 21 squared, and then 22 squared, and so forth. So let's do 21. 21 times 21. 1 times 21 is 21. 2 times 21 is 42. 144. So this is 441. So 425 is between 400 and 441. So between 400 and 441, and we have negative signs here. This is minus 20 basically, and this is minus 21. And so this is going to be approximately, so 425 is closer to 400, or 441 is closer to 441, because the difference is only 16. Here the difference is 25, so it's going to be closer to minus 21. Okay. Next one, tell whether each number is a real number, a rational number, an irrational number, an integer, or a whole number. So minus square root of 169, that's minus minus 13. Minus 13. Square root of 6, this is going to be an irrational number because we don't have a perfect square. Also this one, minus square root of 19. Square root of 1 over 9, that's 1 over 3. Minus square root of 1 over 4 is 1 over 2. Okay, so let's start with the whole numbers first. Whole numbers, we don't have whole numbers for number 10. For number 11, we don't have whole numbers here either. Number 12, here we don't have whole numbers either. Okay, integers. For number 10, integers are going to be minus 1, minus 13, or minus square root of 169 actually. And that's it. So one integer. Then for number 11, we don't have any any integers. For number 12, we don't have any integers. Okay, they're all decimals. So next is real numbers. All of them are real numbers. All the numbers in 10, 11, and 12 are real numbers. Then rational, irrational numbers. So rational numbers here are minus 13 or minus square root of 169, 7.25, and minus 15 over 2. Square root of 6 is not a rational number. That is an irrational number, okay? Because it cannot be represented as a quotient of two integers. For number 11, minus square root of 19, that's an irrational number. It cannot be represented as a quotient of two integers. So there's no perfect square of 19. So that's an irrational number. The other three are rational numbers: minus 4.4, 1/3, or square root of 19, and 0.7. Number 12, all of these are rational numbers. Minus 1/2, or actually minus square root of 1/4, 1.15, minus 0.3, and 7/4. All these are rational numbers. There are no irrational numbers. Number 13, 14, 15, complete the statement. Okay. So square root of 3600, that's 60, because 6 times 6 is 36, and then 2 zeros within the square root convert to 1 0 outside of it. So 60, and then here, is this going to be 900 over 18? Is that going to be 60, greater than 60, or less than 60? Well, 60 times 18 is going to be 1080. So this is going to be less than 60. So 60 is going to be greater. Okay, so let's do it here on the side. So 900 over 18, that's going to be less than 60. Why? Because 60 times 18 is the way I did it is 6 times 8 is 48, 8 and 4, 6 times 1 is 6, and 4 10. So this is 1080 with a 0 here. So 1080. So if we have 1080 over 18, that's 60. Here we have 900 over 18. So we know that this is for sure less than 60. This might be, this actually is probably 50, because 5 times 1 is 5, 5 times 8 is 40. So yeah, this is 50. So 60 is greater than 50. Okay, so that's the sign. We just have to define the sign. Is it less than or greater than? We don't have to compute these numbers. So if you can do it quicker, then that's fine. And you just keep going. Next one is minus square root of 91. So this is minus, and the square root of 91, we know that that's, let me remove this here. So that's 9 squared is 81. And then 10 squared is 100. So 91 is between 81 and 100. So it's going to be between 9 and 10. 91, right here, 91, is it closer to 81 or 100? It's closer to 100. So it's going to be over 9.5. So it's minus 9.5, a little more than 9.5. Okay, because it's 91 is closer to 100. How about minus 104 over 11? 9 times 11, and then we have 10 times 11. 9 times 11 is 99. 10 times 11 is 110. So 104. 104. Is it closer to 99 or 110? 104 is closer to 99. So it's going to be less than 9.5. So this is minus 9. Let's say 49. This is 9.51. So 9.49, because these are negative numbers, smaller the number, greater it is, because it's on the negative axis, right? On the negative side of the x-axis. So minus 9.49 is greater than minus 9.51. Next one, we have square root of x squared. That's basically x. And then we have here x plus 1. So x plus 1 is always going to be greater than x, because here we have x same as here, but here we have plus 1. So the right side is always going to be plus 1. So whatever we have, negative, positive numbers, doesn't matter. The right side is always going to be bigger, because plus 1, we're adding 1 to it. So this is going to be, the sign is going to be like this, less than. Evaluate the expression for the given value of x. When x is 36, we have square root of 36 over 36, sorry, x is 36. So square root of 36 is 6, and then over 36. We can divide by 6, cancel by 6. So 6 divided by 6 is 1, 36 divided by 6 is 6. So 1/6 is the answer. Number 17, we have square root of x. Square root of x is 64, so 64, then over 8 and minus 19. Square root of 64 is 8. 8 over 8 is 1. So 1 minus 19, or this is minus 18. Number 18, mirrors. You're buying a mirror for your room. The store you go to has square mirrors with areas of 225 square feet squared. This is the area. And then the other one is bigger. So this one is bigger. The area here is going to be 6.25 feet squared. Find the side length of each size of mirror. So the smaller one, a squared, is going to be 2.25, or just a is going to be square root of 2.25. If this is square root of 225, that's going to be 15. Right? 15 squared is 225. Now this is 2.25, so this is going to be 1.5 feet. So that's the length, the side length of the smaller mirror. And then the other one, the bigger one, we have a squared is 6.25, or just a is square root of 6.25, or a is square root of 625 is 25. This is 6.25, so 2.5, and this is feet. So 2.5 feet, that's the side length of the larger mirror. So that's it. Number 19, road sign. The US Department of Transportation determines the sizes of the traffic control signs that you see along the roadways. One of the sizes for a square diamond-shaped sign. Okay, so this one right here, it's a diamond, but as you can see here, this is L, this is L, this is L, this is L. So it's basically a square, but it's tilted, so it's a square. It has an area of 2,304 square inches. So the area is 2,304 inches squared. And find the side length. Okay, so this is a squared equals 2,304, or just a is square root of 2,304. Now, if you can use a calculator, you can just plug this in, and it's gonna. But if you're not allowed to use the calculator, then square root of 2,304. So we know that 40 squared is 1,600, right? 4 times 4 is 16, and then 2 zeros. So, and then we have 50 squared, that's 2,500. 5 times 5 is 25, and then 2 zeros, right? So 2,304 is between 40 and 50. It's going to be somewhere here. Now the last digit is 4, so 2,304 is very close to 2,500. Is closer to 2,500 than 1,600. So we know that this is going to be over 45. So it's either going to be 46, 47, 48, or 49. Now the last digit is 4, so 6 times 6 is 36. 6 is the last digit, so that's not it. 7 times 7 is 49. That's not it. 48. 8 times 8 is 64. Yep, maybe it's that one, right? So let's just see. 48 times 48. 8 times 8 is 64. 4 and 6. 4 times 8 is 32, and 6 38. 4 times 8 is 32. 2 and 3. 4 times 4 is 16, and 3 19. So we have 4, 0 and 1. 3 and 1, 2,304. 2,304. That's exactly it. So it is 48. So 48 inches is the side length of the sign. That's A. 19A is 48 inches. B, how many signs can be made from a piece of sheet metal that is 4 feet long, 4 feet long, and 8 feet wide? So this is in inches, this is in feet. We have to convert into feet. 1 feet is has 12 inches, so we just have to know that, right? 1 feet has 12 inches. So 4 feet, that's 4 times 12, that's 48 inches. Then 8 feet times 12, this is 96. 96 inches. So this is 8 feet or 96 inches, and this is 4 feet or 48 inches. Once again, we have 48 inches here as the length, and the width of 96 inches. 96 is basically 48 plus 48. So in a way, we have 2 signs can fit into this metal sheet area. So we have, the answer is 2 for B, 19B. And number 20, we have one of the porthole windows on a ship has an area of 200.96 square inches. Another porthole window has an area of 615.44 square inches. The diameter of the windows can be found using the expression, this one, where A is the area of the window. Find the diameters of the windows. Okay, so let's do the first one first. So 2 square root of A, which is 200.96 over 3.14. This is going to be, what is 200? We have 200.96 divided by 3.14, that's 64. So square root of 64 is 8, so 2 times 8 is 16, so 16 inches is the diameter of the first window, the one that has the 200.96 square inches area. And then the second window, we have 615.44 over 3.14, or this is 615.44 divided by 3.14, that's 196. So this is 2 times square root of 196 is 14. So 2 times 14 is 28. So 28 inches is the diameter of the second window. So that's all for today. Please like, share, and subscribe. And I'll see you next time. Thank you. Bye-bye.